The ocean around Isla Guadalupe is not the kind of place that makes you feel small in a comfortable way. It makes you feel small in the way that reminds you the world is much larger and much older than anything you have ever known. Located roughly 150 miles off the coast of Baja California, Mexico, this remote volcanic island sits in deep, cold Pacific water where the seafloor drops away into darkness almost immediately. There are no shallow reefs here, no gentle sandy bottoms to rest your eyes on. There is only blue, fading into darker blue, fading into nothing. And in that nothing, great white sharks have been gathering for as long as anyone has been paying attention. Scientists and researchers have studied this location for decades precisely because the water clarity here is exceptional near the surface. On a calm day, you can see a shark approaching from 30 or 40 feet away, which in shark diving terms is considered a luxury. But what happened during one particular research and dive expedition at Isla Guadalupe turned that luxury into something much more unsettling. A group of divers, positioned inside underwater cages designed for close observation, were doing exactly what people come to this island to do. They were watching great white sharks. And then one shark swam past, and everything changed. She was a large female, estimated at around 15 feet in length, which places her firmly in the upper range of what researchers commonly encounter at Guadalupe. She moved the way large female great whites tend to move, with a kind of slow and deliberate confidence that comes not from aggression but from simply never having had a reason to hurry. The divers inside the cages had seen dozens of sharks by this point in their trip. They knew the rhythms. They knew how to read the body language. But as this particular shark turned her body slightly in the water column, catching the light at a different angle, something stopped them cold. Along her midsection, wrapping around a large portion of her torso in the area just behind her pectoral fins, was a scar. Not the kind of scar that accumulates over a life lived in rough conditions. Not the small parallel lines left by the teeth of another shark during a territorial dispute. This was something else entirely. It was a large, curved, almost circular mark that covered a significant portion of her body. Clean in its edges. Wide in its arc. The kind of shape that forces you to think about what geometry of jaw could possibly produce it. The footage recorded during this encounter was later examined by marine researchers, and the details they focused on were precise. The placement of the scar was unusual. Sharks that engage in competitive or aggressive behavior with one another tend to go for specific anatomical targets. The head and gill region are vulnerable. The caudal fin area is another common target. These are the zones where a bite causes functional damage and sends a clear message. But this scar was centered on the mid-body, the broadest and most muscular section of a large shark. That is not where sharks typically bite each other. The shape also drew significant attention. The curvature of the wound suggested a jaw of extraordinary width, one that would need to span a distance far beyond what standard great white shark anatomy produces at normal sizes. Researchers who studied bite mechanics pointed out that for a great white shark to leave a scar of that particular arc and diameter on a 15-foot female, the attacking animal would need to be substantially larger than anything currently documented with regularity. Estimates varied, but the conservative figures placed the attacker somewhere in the range of 20 feet or beyond, possibly significantly beyond. To understand why that number matters, it helps to know where great white sharks actually sit in the scale of documented size. The species, Carcharodon carcharias, is genuinely large by any biological standard. Adult females, which grow larger than males, commonly reach lengths between 11 and 16 feet. Exceptional individuals have been recorded at greater lengths, with the shark known as Deep Blue, a large female photographed near Guadalupe and later near Hawaii, estimated at approximately 20 feet in length and believed to be one of the largest verified great whites in modern scientific record. So when researchers begin working backward from a bite scar and arrive at an attacker larger than Deep Blue, they are entering territory where documented evidence becomes very thin and the questions become very loud. It is worth addressing one explanation that came up quickly and was also quickly questioned. Mating behavior in great white sharks does involve biting. Male sharks bite females during courtship, and this leaves marks. However, mating bites in sharks have a distinct character. They are typically found near the pectoral fins or on the trailing edges of the body. They are elongated rather than broadly circular. They are also usually shallower in terms of tissue damage, functioning more as a gripping mechanism than a predatory strike. The scar observed on this female did not match that profile in location, shape, or apparent depth. Researchers who specialize in shark reproductive behavior looked at the imagery and largely ruled out mating as a plausible cause. That left the question open in a direction that was harder to answer comfortably. The encounter did not end with just the observation of the scarred female. Sometime after she passed, divers and crew members noticed something that experienced ocean observers have described before in contexts involving large predators. The water became quiet. Not gradually, not through the slow drift of animals elsewhere, but in the way that suggests something altered the behavioral calculus for every creature in the area. Sea lions that had been visible near the surface disappeared. Other sharks that had been circling the vicinity moved away or dropped lower in the water column. Schools of fish that had been shifting and regrouping in that particular patch of ocean were suddenly absent. Marine biologists who study predator-prey dynamics have documented this phenomenon in multiple ocean environments. It is sometimes called the landscape of fear, a term that describes how the mere presence of a dominant predator changes the movement and behavior of other animals even before any attack occurs. Prey animals and even subordinate predators respond to signals that humans often cannot detect: pressure wave changes, low-frequency sound, chemical traces in the water. When everything in an area leaves at once, experienced divers and researchers know to pay attention. What the detection equipment on the dive vessel then began to register added a concrete dimension to what the biological behavior of the surrounding animals had already suggested. A large mass was rising from deeper water. The depth readings shifted steadily. The ascent was not erratic. It was not the random vertical movement of an animal caught in a current or startled into action. It was measured, direct, and continuous. When a brief visual contact was made with the ascending shape, the detail that registered most sharply was the tail. Witnesses described it as spanning roughly 8 to 9 feet across. For context, a great white shark's caudal fin width scales proportionally with body length. A tail measurement in that range corresponds to a total body length that pushes toward the upper boundary of what has been observed in the species and potentially beyond it. The animal that eventually became visible to divers was estimated by those present, and later by researchers reviewing footage, to be somewhere in the range of 23 to 24 feet in length. It was covered in old, healed scars across much of its body. It moved with the kind of economy that very large, very experienced animals tend to display. No wasted motion. No apparent agitation. It navigated around the cage structure in a way that suggested spatial awareness and deliberate positioning rather than random investigation. This animal was later given the informal name Colossus by those involved in the encounter and subsequent study. The name reflects less a desire for drama and more an honest acknowledgement of scale. When the bite measurements from the scarred female were compared against estimates of Colossus's jaw dimensions based on body length, they aligned. The researchers' conclusion was that the circular scar on the 15-foot female had very likely been made by an animal matching the size and dentition profile of the enormous shark they had observed. This was not a monster from mythology. It was a great white shark. The same species that tourists observe on cage dives every season. But it was a great white shark at the far edge of what the species is biologically capable of producing, an individual that had survived long enough and grown large enough to occupy a position in its environment that no other animal in those waters could challenge. The scientific significance of this is worth sitting with carefully. Great white sharks grow slowly and live for a long time. Research published in journals including PLOS One and work conducted through tagging programs run by organizations like OCEARCH has established that great whites may live for more than 70 years, with growth continuing at a slow rate throughout much of that lifespan. An animal with 50 or 60 years of Pacific Ocean experience, fed consistently in a rich environment like the waters around Guadalupe, could theoretically reach dimensions that far exceed what researchers encounter on average expeditions. The ocean is large, and the individuals within a species that reach extreme age are not often the ones swimming near the surface in daylight hours. They are the ones in the deeper, colder water below, where observation is rare and documentation is difficult. There is a tendency in popular media to leap from large unexplained ocean phenomena to suggestions of Megalodon, the enormous shark species that went extinct approximately 3.6 million years ago according to the scientific consensus. It is an appealing idea in the way that most enormous ideas are appealing, but the evidence for any surviving Megalodon population is non-existent in the scientific record. The oceans are extensively monitored through tagging programs, acoustic arrays, deep-sea camera systems, and submarine research vehicles. Megalodon, which fed on large marine mammals, would need to consume them in quantities that would leave a trace. There is no trace. Paleontologists, marine biologists, and oceanographers are consistent on this point. What makes the Guadalupe observations significant is not that they hint at something extinct. It is that they remind researchers how much remains to be documented about species we already know exist. The encounter near Guadalupe and the scar that started the entire chain of investigation raise a serious and legitimate scientific question about what the true upper size limit of Carcharodon carcharias actually is in the wild. The largest individuals of any long-lived species tend to be rare, often solitary, and typically inhabit areas that see low human traffic. Deep water, remote geography, cold temperature zones. These are the same characteristics that describe the environment immediately below the surface observation zone at Isla Guadalupe. What divers see from inside cages is the top layer of an ecosystem that extends thousands of feet below them. The animals that move through the deeper sections of that water column are known through indirect evidence, through tagged sharks that suddenly descend to extreme depths and return, through acoustic signals, through the behavior of other species reacting to presences they detect and humans do not. The scar on that female shark was a piece of direct physical evidence from a depth and a context that rarely produces such clear documentation. What researchers took away from the Guadalupe observations was not a confirmation of myth or a reason for panic. It was a data point, an unusual and striking one, in the ongoing effort to understand how the apex predators of the Eastern Pacific actually live, grow, and interact across the full range of their environment. Great white sharks at Guadalupe are studied with a seriousness that reflects genuine scientific value. Organizations including the Pelagic Shark Research Foundation and various university research programs have used the island's clear water and reliable shark presence to collect tagging data, behavioral observations, and biological samples that contribute to conservation planning. The female with the circular scar was catalogued. The footage of the large ascending shark was analyzed. The behavioral patterns of other sharks in the area during and after those encounters were documented. What the ocean around Isla Guadalupe ultimately demonstrates is not that it is more dangerous than we thought, though respecting it is always appropriate. What it demonstrates is that it is more complex than any single expedition can fully capture. The great white sharks that gather there each season are part of a population with individuals spanning a range of ages, sizes, and histories that science is still working to fully characterize. Some of those individuals are young animals on their first season in the area. Some are mature females returning on cycles tied to feeding and reproduction. And some, if the evidence from this encounter is taken seriously, are ancient animals of extraordinary size that carry decades of the Pacific Ocean's history in their scars and their behavior. The bite on that 15-foot female was not just a wound. It was a record. A record of an interaction between two animals at the top of an ocean food web, in water too deep and too dark for human eyes to follow, leaving behind on the body of one survivor a shape that told a story larger than the shark herself. And the story it told was simple. The ocean is deep, the animals in it are old, and we are still very much at the beginning of understanding what lives beneath the surface.